Hi everybody, Mr. Rubo here. Today we are doing topic 2.6, which is competing function model validation. So we've looked at many ways of creating models given a data set. Right now, we've really focused so far in this course on three. We've talked about linear, quadratic, and now exponential. Models. These are the three that will happen the most frequently in real world situations, and they're the most important for this course. So, if we're talking the AP exam, students are going to be expected to determine which model is most appropriate. Okay. And pretend I know how to spell appropriate. There we go. Given a set of data. So, a few strategies we're going to use determine whether it's linear, quadratic, or exponential for the most appropriate data. So, for linear, we have this nice linear example. You can see our line of best fit. You can see the data. Well, we're going to use a linear model when the data reveals a relatively constant rate of change, which should make sense, right? If it seems like they're changing at a constant rate or pretty close to it, linear is our best model. Okay. For quadratic, on the other hand, we've talked about this before, that use a quadratic model when the rates of change are increasing or decreasing at a relatively constant rate. Constant rate. Okay. So again, if our rate of change is increasing every 2 or 3, right? Something close. You will use quadratic. Also, in general, if you look at the data points and they have a U shape to them, kind of that's another good indicator just to the eye. Okay. The last one is exponential. How do we tell this one? Well, this is when they are proportional, or roughly proportional. Okay. So each successive output is approximately the result of repeated multiplication. Again, it's that idea that you look at the outputs and you're like, oh, this is double. Oh, and then if I double it again, I'd get something like 2, which is pretty close to 1.9. If I double that, it's about 4, which is pretty close to 4.2. If I double 4, I get 8, which is pretty close to 8.8, right? You'll have some variance, but that's kind of how we tell, right? Where all the other ones, you're looking just at the rate of change, right? We're changing up, 1.5 to just under 2. Like you're changing by the same amount every time, or pretty close to it. Here, we're not changing by the same amount every time, but you would then look at that that change and see how it's changing. And also, again, looking at the data points, we can kind of clearly see a U shape to it. Exponential, you're seeing it double, triple, whatever it might be every time. And that's how we tell that one. Okay. We'll do some examples in class, but that's it for today's video. Thanks for watching.